This one is really tricky. Okay, again, let's have you and your partner do domain and location of discontinuity. Okay, no matter what you do, you always factor first. So this is x minus 4 times x plus 1 over x minus 4. You can see that it cancels. So that domain is not equal to 4, but that 4 is a removable kind. Okay, y-intercept, easy. 0, 1. X-intercept, okay, this one's really tricky. So x-intercept, if you look at it, there are two numbers that will make it 0, right? Because the numerator has two factors. However, one of them is going to make a whole. That whole cannot be a 0. So then what you actually have to do is find the reduced function, which is just x plus 1. So cancel out all the factors, the leftover, and make that equal to 0. So the x-intercept is only minus 1, 0. So this is the tricky part. The x-intercept cannot be a whole. So whatever was the whole cannot also be on the x-axis. All right. Let's just give you the definition, and we may do a little bit of practice. Okay, so vertical asymptote is the invisible line, vertical lines that the graph does not cross. Okay, only when the denominator does not cancel with the numerator. Okay, that is the vertical asymptote. Okay, so homework tonight, you're only going to do up to vertical asymptote. I think the homework does have horizontal asymptote. You're going to skip that for now because it takes a little bit of time to go over that. And I don't want you guys to be confused, so we're just not going to do that for now. Okay, so that is it for notes today. Let's do some practice. Huh? Wait, what? Okay, so that's it for that. We're going to look at horizontal asymptote. There are three cases, but let's kind of talk about what horizontal asymptote is. It is an invisible line that the graph does not cross, and it's going to be a y equals a number because it's horizontal. Now, the thing about horizontal asymptote is it does not cross near the origin. Outside the origin, but near the origin, sometimes it does cross. So don't be alarmed if your point is exactly on the horizontal asymptote. Okay, let's look at the three cases. There are three cases to tell what kind of horizontal asymptote you're going to have. Case number 1, when the degree of the numerator is equal to the degree of the denominator. All right, let's talk about this. Let's look at this question here. Y equals 3x minus 1 over 2x plus 2. Let's look at the numerator. 3x minus 1. What is the degree of 3x minus 1? 1. Because there is an invisible 1 on the x, and the highest number of that polynomial is called the degree. Okay, so let's look at the denominator, 2x plus 2. What is the degree of 2x plus 2? Everybody? 1. Okay, so are the degrees the same? Yes. When the degree is the same, the horizontal asymptote is the ratio of the leading coefficient. When the degrees are the same, the horizontal asymptote is the ratio of the leading coefficient. Okay, let's talk about some words. Ratio. What does ratio mean? Everybody's just like waiting for someone to answer. Okay, let's have you talk to your partner really quickly, 5 seconds. What does ratio mean? Okay, Sally and Nathan, what does ratio mean? Good, fraction. All right, next. Leading coefficient. Okay, talk to your partner. What is the leading coefficient? Sorry, Samantha. Okay, Rula and Josh. What is the leading coefficient? How do you know? Where is it?
It's like the number before the highest.
Yes, perfect. The number before the highest degree. Okay, so when the degree of the numerator and the degree of the denominator is the same, the horizontal asymptote is the ratio of the leading coefficient. Okay, so let's look at the top. 3x minus 1. What is the leading coefficient? 3. Okay, and the denominator, 2x plus 2. What is the leading coefficient? 2. Okay, so then what is the ratio of the leading coefficient? 3 over 2. Okay, so this horizontal asymptote is at 3 over 2. And that is because the degrees are the same. All right, that's first case. Second case, when the degree of the numerator is less than the degree of the denominator. Okay, let's take a look at this again. Y equals 3x minus 5 over x squared plus 1. What is the degree of the numerator? 1. What is the degree of the denominator? 2. Is the degree on the top smaller than the bottom or bigger than the bottom? Smaller. Okay, when it's smaller, it's just 0. Why is that? Because the bottom is expanding a lot faster than the top. So like for example, if you have 1 over like 1 million or something. If you put that number in the calculator, it's almost like 0. So when the bottom is expanding faster than the top, it's almost like 0 because the bottom is moving too fast. Okay, so then this is what happens. Second case, when the numerator degree is smaller than the denominator, it's almost like 0. Okay, last case. When the degree of the numerator is bigger than the degree of the denominator, okay, let's look at that example here. X cubed plus 4 over x squared plus 1. What is the degree of the numerator? 3. What is the degree of the denominator? 2. So which one's bigger? Numerator. So then when that happens, the top is expanding faster. There is no horizontal asymptote. There is no horizontal asymptote. Instead, there is a slant asymptote. There is a slant asymptote. Well, we're not going to do slant asymptote this year. We'll do that next year. You just need to remember there is no horizontal asymptote. That's it. All right, let's practice. Find the vertical and horizontal asymptote. I think you guys can do this. Okay, vertical asymptote, whatever does not cancel out in the denominator. Horizontal asymptote, check those 3 cases. Is the degree the same? Is the degree bigger on the top? Is the degree bigger on the bottom? All right, let's see. Sam, what is the vertical asymptote? No, not sure. Okay. Let's see. Alana, what is the vertical asymptote? X is 3. Okay. Let's see who else. Mark, what is the horizontal asymptote?
Y is 2.
Good. All right. Let's try another one. Okay, do the same thing, except this time you're going to have to factor. Okay, Blake, where are the vertical asymptotes? Good. Oops. X equals 3 and -1. So if you're still not writing the x equals 2, please make sure you do that. Andy, where is the horizontal asymptote? You're not sure, guess.
Equal
2? No. So let's look at the degree. The degree on the top is 1. The degree on the bottom is 2. So is the top bigger or smaller? So then what is the horizontal asymptote?
0.
Yes. All right. Now let's have you try this one. Let me know when you're done. All right, let's try Isabella. Vertical asymptote.
X is equal to -2 and 2.
Mm-hmm. And then Sally, horizontal asymptote. Good. All right, now we're gonna put all that together and do one big one. So we're gonna do domain. What kind of discontinuity? Where? X-intercept, Y-intercept, vertical asymptote, horizontal asymptote. VA and HA is the vertical asymptote and horizontal asymptote. Okay, so go ahead and do that. Work with your partner if you get stuck. All right, who did we stop on? I think Josh, right? Okay, Josh, what is the domain? 2 and -2 or not equal to 2 and -2? Not equal to 2 and -3. 2 and -3. Okay. Rula, what kind of discontinuity and where? Uh-huh. Okay. All right. Sally and Nathan, did I call you guys before? No. I did. No, not yet. Okay. Thank you for being honest. Okay, Sally, where's the x-intercept? I did not call you before. Did I call Nathan? No. Nathan, where's the x-intercept? Good. All right. Coming back to Evan. Where's the y-intercept? -1. So 0, -1. Okay. Sebastian, vertical asymptote.
X equals 2, -3.
Good. And then Daniel, horizontal asymptote.
Oh, dang.
No. Okay.
But is there?
Yes, but do you know why?
Yes.
Why?
The degree's wrong.
Okay. All right. Someone help Daniel out. Why is it 0? What's the degree on the denominator? In the denominator? 2. There are 2 x's, so the degree is 2. So then the degree in the denominator is bigger, so then it's gonna expand faster. So it's gonna be 0. All right, let's graph. We're going to skip the first one. The first one's too easy. Let's do the second one. We're gonna analyze as is, and then let's graph it together. So you already know how to do all this stuff. Vertical asymptote, horizontal asymptote, x-intercept, y-intercept, and then we're gonna graph together. Let's start with Allison. Where is the vertical asymptote? Good. Alice, where is the horizontal asymptote? Yes, y equals 1. Sam, do you think you can find the x-intercept? Good. And then Samantha, where is the y-intercept? Yes, 0, -1/2. All right, so what we're gonna do now is just graph all those things on the graph first. So 4 things. Vertical asymptote is at -2. Y-intercept is at 1. And we have 2 points, 1, 0, and 0, -1/2. Okay, so at least get those 4 things on there. The 2 asymptotes and 2 points. Well, that's not very interesting. We can't really tell how this graph is going to look like. Except we know that the graph is always going to try to go to the asymptote. It's kind of like a magnet. The asymptotes are like magnets. It's going to pull the graph towards the asymptotes, and then it's never going to cross. So what we can do basically at this time is just make the graph connect and then go to the asymptote. There's really no other way to graph this because it's going to try to go to the asymptote. And this is basically like the graphs that we did, for 8.2, where when we have 2 asymptotes like a cross, they are symmetrical. So then the other side is going to look like that. We don't really know exactly where it is unless you plug in points, but we know it's going to be a symmetrical graph. Okay, good? Easy? Okay, so basically you want to analyze it first with all the stuff that you know about it before you actually put it on the graph. Okay, let's try one. So this one you're going to practice. Again, vertical asymptote, horizontal asymptote, x-intercept, y-intercept, and then you're going to draw those things on there and then try to make the points go towards the asymptotes. All right, let's start with Giselle. Where is the vertical asymptote?
X is not equal to 3.
Actually, the domain is not equals 3, but then, yeah. So the vertical asymptote is at 3. Brady, where is the horizontal asymptote?
Y equals 3.
Okay, Trey, x-intercept.
1, 0.
1, 0. 1, 0? No.
2, 0.
No.
Okay. I did something.
Oh, did you look at the wrong question? Maybe, no. Oh no. Okay, make the numerator 0. Okay, so Chad, where's the x-intercept?
1,
1/2, 0. And then,
Oh, I switched it.
you switched it? Okay, so do you have the y-intercept?
No.
Okay.
Don't call me. Don't call me.
Oh, Trey. Okay, Mark, do you have y-intercept?
0, -1 over here.
Okay, so now let's go ahead and graph this. X equals 3, y equals 1/2, -1/2 is 0. 0, -1/3. Okay, so probably something like this and like this. Okay, give me a thumbs up if you got this graph. Okay, all right. Okay, let's go on to the next one. Now it's going to get a little harder, but we will be fine.